Hi guys, this is Mrs. Denton again. Today we're going to do lesson 8.3, Samples and Populations. Grab you some notebook paper, put your heading on there, let's get started. Your warm-up says you flip a coin and roll a number cube. Find the probability of the event. Now, you can use the fundamental counting principle, or you could make a tree diagram. Go ahead and pause the video, take some time, and see if you can calculate the probability for each of these 4 events. Pause the video if you need to. Okay, if I wanted to think about this like a tree diagram, I could come over here and I could write out my coin possibilities and my number cube possibilities. So with my coin, I can either flip a head or a tail. With my number cube, I can get a 1, 2, 3, sorry, that's horrible, 4, 5, and 6. So there's my options for if I flip a head, I can get each of those on the number cube. If I flip a tail, it's the same thing. I can still get number 1, 2, 3, 4, 5, or 6 on the number cube. Now I could also take my options here. Number of outcomes for a coin is 2 times the number of outcomes for a coin. A number cube, and I could get 12 as well. So either one of those options work. Number 1 says flipping a head and rolling a 6. So I'm going to come over here and I'm going to see how many of these have a head and a 6. So this and this, and nothing from the tail. So I have 1 out of 12, which is the same thing as 8 and 1/3% probability. Number 2, flipping a head and rolling an odd number. So we're going to come over here to the head. 1's an odd, 3's an odd, 5 is an odd. Disregard this one right here that we did earlier. So I have 3 possible outcomes for this event out of 12 total possible outcomes. So 3 out of 12 simplifies to 1/4, which is the same thing as 25%. Okay, number 3, flipping a head and rolling a number greater than 3. So let me switch colors here so we can look at a number greater than 3. So we still want the head and a number greater than 3. It can't include 3, it has to be greater than 3. So we would have a 4, a 5, and a 6 for that possibility. So 3 out of 12, and we just did that on number 2, so we know that's the same thing as 1/4, which is 25%. Number 4, flipping a tail and rolling a number less than 5. So now we're going to switch down here to the tail and a number less than 5. We're not going to include 5. We're going to go less than 5. So a 4, a 3, a 2, and a 1. That would give us 4 options. So 4 out of 12 is the same thing as 1/3, which converts to 33 and 1/3%. Okay, we've got a couple vocab here. A population is an entire group of people or objects. So you could have people or objects, but it's the entire group. A sample is part of the population. So keyword part of the population. So we take a sample out of the population, which is the entire group. A couple other important vocab that we're going to talk about is a random sample. The word random in math is just like it means. in the real world. It's a representation of a population. So it's a random sample from the population. It is selected at random and is large enough to provide accurate data. A biased sample, or sometimes called a limited sample, is not representative of a population. One or more parts of the population are favored over others. That's what makes it biased. If something is favored over other options, then it's what we call biased. Okay, example 1 says identifying random sample. You want to estimate the number of students in a high school who ride the school bus. Which sample is a random sample? So we're looking for a random sample. 4 students in the hallway, all students in the marching band, 50 seniors, or 100 students during lunch. So let's talk about each one of these. In part A, 4 students in the hallway. Do you think that is a good enough sample if we're talking about an entire high school? Choice A is not large enough to provide accurate data. We want an entire high school, so 4 students is not nearly enough. Part B says all students in the marching band. Now, I underlined marching band because they were all involved in one particular aspect of the high school. So choice B wasn't selected at random. Choice C, 50 seniors. Now, I put a mark underneath seniors because that's pulling out just a certain group of students from the high school. Choice C is not representative of the population because seniors are more likely to drive to school than other students. Their age allows them that. And choice D says 100 students during lunch. 100 is a fairly large number, and during lunch is a very random selection. It's not in the band or a certain age group. So choice D would be representative of the population, selected at random and large enough to provide accurate data. So choice D is a random sample in this example. Okay, some more important info that you need to be looking for. The results of a random sample are proportional, keyword proportional, to the results of the population. So a random sample is proportional to the population. So you can use random samples to make predictions about the population. Biased samples or limited samples are not representative of the population. So you should not use them to make predictions about the population because the predictions may not be valid. So we really can't set up a proportion if it's not going to be valid. Okay, example 2 says, determining whether conclusions are valid. You want to know how the residents of your town feel about adding a new stop sign. Determine whether each conclusion is valid. Part A says you survey the 20 residents who live closest to the new sign. 15 support the sign and 5 do not. So you conclude that 75% of the residents of your town support the new sign. Do you think that conclusion is valid? Look at some points here that we have. We've only surveyed 20 residents who live closest to the new sign. So 20 something to think about who live closest to the new sign. 15 support, 5 do not. So you make a conclusion that 75% of the residents of your town support the new sign. The sample is not representative of the population because residents who live close to the sign are more likely to support it. They want the sign there. So the sample is biased and our conclusion is not valid. So biased sample, not valid conclusion. Part B, you survey 100 residents at random. 40 support the new sign, 60 do not. So you conclude that 40% of the residents of your town support the new sign. So 100 residents at random, that changes a lot of information here. So your conclusion that 40% of the residents support the new sign, would that be more likely to be valid? Yes, the sample is representative of the population selected at random, large enough to provide accurate data. So we say this sample is unbiased, so our conclusion would be valid. So if it's biased, it's not valid. If it's unbiased, then we can say it is valid. Example 3, making predictions. You ask 75 randomly chosen students how many movies they watch each week. There are 1,200 students in the school. Predict the number N of students in the school who watch one movie each week. Now, over here, we have a graphic that we can go by as well. You ask 75 randomly chosen students. That's what our graphic is based on. There are 1,200 students in the school. So we have our sample, and then we have our total population. Predict the number N of students in the school who watch one movie per each week. Now, we're going to take the information over here in the table that's based out of 75, and we're going to set up a proportion. So let's use our sample. And one movie each week is in this green section. So we have 21 out of a total of 75. And now we're going to predict the number of students in the school. So this is our population that we're working with now. So we have 1,200 students, and we're wanting to predict the number out of the entire population or school. So we're going to replace that with N, the variable in our information. And remember, in 7th grade proportions, sometimes in 6th grade, you can set this up a multitude of ways. You can cross multiply and make them equal. You could even write it out and create an equation. So if I took 21 times 1,200, I want that to be equivalent to 75 times N. So if I can go ahead and put that into my calculator, I'm going to get 25,200 equals 75N. Now, to solve this, I would divide both sides by 75. So that's already in your calculator. 25,200 divided by 75 equals 336. So we are going to say about 336 students watch one movie each week. So as long as we have an unbiased sample, random sample, we can set up a proportion to make a prediction that is valid. The sample is representative of the population selected at random and large enough to provide accurate data, so the sample is not biased and you can use it to make a prediction. And there's the formula that we just used to set up the proportion to solve that information.